Guys, today we're going to talk about patterns and what we call inductive reasoning in geometry. So in geometry, we're often asked to look for a pattern or describe a pattern. So what do we mean by that? So when we ask you that, we expect you to look at examples, describe how it starts, and how to get to the next number or the next picture. So let's look at example 1. We need to decide what's happening. So it looks like we're starting with something with 3 sides, and then we have 4 sides, and then we have 5 sides, and then we have 6 sides. So basically what's happening is we're adding a side each time. So when we go to describe this, the first thing you have to do is tell me where it starts. So starting with 3 sides, add 1 side each time or increase by 1 side each time. Now look at example 2. It says describe the pattern and predict the next number. So this has got 2 parts. So we're going to do what we did in example 1, and then we're going to predict the next one. So let's look at example 2. So what we have to decide is what is it taking us to go from 1 to 4, from 4 to 16, from 16 to 64. So the numbers are increasing. That means we're either adding or we're multiplying. So if I tried to add, to get from 1 to 4, I add 3. Well, I have to do more than add 3 to get to the next one, so that doesn't work. So what would we have to multiply by? So to go from 1 to 4, we multiply by 4. 4 times 4 is 16. 16 times 4 is 64. So that means we're multiplying by 4. So in this case, we're going to write starting with 1, we multiply by 4 each time. And to predict the next number, we just take 64 times 4, and we get 256. So we said where we're starting from, we said how to get to the next one, and we made our prediction. So I want you to go ahead and look at part B. We know we start at 17. We know it's decreasing. That means you're either subtracting or you're dividing. And I want you to decide what is actually happening there. All right, so hopefully you decided it was subtraction. So in this case, if I subtract 2, I get 15, then subtract 3, then subtract 4, then subtract 5. So our next number is going to be 3. To write this, it's a little bit more complicated. So starting with 17, we subtract or decrease by the next consecutive number, starting with 2. I know that sounds kind of confusing, but basically we're subtracting each one. You could say starting with 17, subtract 2, then 3, then 4, and so on. That works too. Okay, so as we've seen, there's more than one way to describe how to get to that next one. Like in part B, we could have said subtract by the next consecutive number, or we can do it the way we did and just say subtract 2, then 3, then 4, and so on. We've established a pattern. You can see that the next one would be 5. So patterns help us reason in geometry, and there are 3 stages in this inductive reasoning process. So stage 1 is look at the examples, which we did. Look for a pattern, so what do you see happening? And then we make a conjecture or a prediction. So a conjecture is just a prediction. So as I said, that's inductive reasoning. So look at examples, try to find a pattern, make some kind of a conjecture or a prediction. So look at example 3. It says write a conjecture that describes the pattern. Movie show times are at 8:30, 9:45, 11, 12:15. So just like we did in the number examples, we're going to try to figure out how this is changing. So to go from 8:30 to 9:45, that is 1 hour and 15 minutes. To go from 9:45 to 11, again, that's 1 hour and 15 minutes. To go from 11 to 12:15, again, that's 1 hour and 15 minutes. So basically, movie show times occur every hour and 15 minutes. So that is what we mean by make a conjecture. Okay, sometimes this isn't quite as easily done. So look at example 4. The product of a negative number and a positive number is blank. Well, we're probably going to have to look at some examples of a negative number times a positive number. So for instance, negative 1 times 3 is negative 3. Negative 2 times 4 is negative 8. Negative 5 times 5 is negative 25. So if I look at these, think about what each of those have in common. Okay, hopefully you realize that each one of those is negative. Look at example 5. The sum of an odd number and an even number is blank. So again, we're going to look at some examples. The sum of an odd and an even. Sum is add, by the way. So 1 plus 2 is 3. 3 plus 2 is 5. 3 plus 4 is 7. So if I look at these, let's do -1 plus 4 is 3. -5 plus 2 is a -3. So I tried to show you some examples because those first 3, they were all positive, but that doesn't have to be the case like in the last example I showed you. But what they do all have in common is that they are all odd. So negative, positive, odd, even is kind of a common theme for some of these like that. Okay, note, just because something is true for some examples does not mean it is true for every example. To prove a conjecture false, you need a counterexample. And a counterexample is just something that is false. Okay, so let's look at example 6. It says, find the counterexample. It says the difference between two positive numbers is always positive. So we know difference means subtract. So it's saying if I subtract two positive numbers, I have to get a positive answer. Well, if I took 2 minus 5, I get a -3. Now, both of those were positive numbers. I did a subtraction. I just put the biggest number second, which makes it negative. So that would be a counterexample. It's an example that makes that statement false. Part B says the sum of two numbers is positive, or if the sum of two numbers is positive, then the numbers must be positive. All right, well, if I took a -1 plus 5, I get a +4. So I have a positive answer, but both of the numbers weren't positive. So again, that is a counterexample. It's a statement that's false. When you multiply a number by 2, the product is greater than the original number. Well, if you did -1 times 2, you get a -2. -2 is smaller than -1. You could do 0 times 2, you get 0. Again, 0 is not bigger than 0. So again, that is a counterexample. The last one says, if the name of a month starts with the letter J, it is a summer month. All right, so can you think of a month that would not be a summer month that starts with the letter J? Hopefully you chose January. Because again, that is a false statement. It's a month that starts with J that is not a summer month. So this is all about looking for patterns, being able to predict something, and then looking at some examples and figuring out something that would make it false. So in the Google form you're about to do, it's going to make you do all of these different categories. Remember, if you have questions, please feel free to contact me. All right, see you soon.